Alright class, we're going to pick up this morning as a continuation on our lesson, our unit in geometry. We've talked a little bit so far about polygons being closed-sided figures with at least 3 line segments. That's where our polygons come from. We've talked about regular and irregular. We're going to look at that again in just a minute. We've talked about congruent figures. We should know by now that a congruent figure must be the same size and the same shape. They have to be both or they are not congruent. This is where we get into the difference between regular and irregular polygons. We're going to be looking at quadrilaterals, 4-sided figures, as well as triangles, and we're going to be looking basically today at how to find the area of some of these figures. Now this will not be all-inclusive. There will be other items that we'll add to this lesson in class in the days ahead that we'll do a little bit each day. But this is just going to basically be a background lesson today to get you started, so you'll have some idea of what we're doing, and then we will expand upon it each day, hopefully in class. Again, we know that a regular polygon has all sides and all angles congruent. That's your regular polygon. Irregular polygon is anything that has sides or angles that are not equal. By now we are quite familiar with the fact we know that something like this looks like a rectangle. We know that we have 2 pair of parallel sides. This line, this side and this side are parallel, as well as this one on top and the one on the bottom. These terms I think we've heard probably last year, but we're going to review those again. If I have a rectangle with a length of 10 and a width of 5, we want to look first at perimeter and review that. Perimeter just means simply all the way around something. Most of you are familiar with Atlanta city traffic to some extent. They have what they call 285. 285 is a perimeter highway that runs all the way around the city of Atlanta. So think about that. Valdosta has a perimeter road. Ours is not complete, but basically a perimeter goes all the way around. Generally we'll make a circle, but it covers everything around. So if I've got 10 on top, then this side must also be 10 as well. If I've got a width on this end of 5, this must also be 5. So if I want to find perimeter, I simply add these together. 10 plus 10, of course, 20, 25, and 30. My perimeter of this figure would be 30 inches, centimeters, whatever we want to label it. Now, the difference in perimeter and area, real simple, no big deal, a little bit of multiplication. If I want to find area, area simply is defined as L times W, or of course length times width. If this rectangle has a length of 10, a width of 5, then 10 times 5, of course, is 50. So we see that this rectangle has a perimeter of 30, we'll call it inches, 30 inches, but it has an area of 50. Now one thing we have to be sure about when we're doing area, we're talking about square units. So we must label this as square inches, or we can call it inches squared. Either one is acceptable. We can write it either way. Now we'll look at this a little bit more in class, perhaps with an activity. But when we're talking about squares, the square area of something, we're talking about how many times we could lay 1 inch on this entire figure. Now, of course, we're not attempting to draw that up here. 1, 2, 3, 4, 5. Whoops, got one too many. But we can lay down 50 tiles on the inside of this figure. Now, you can relate that to everyday life quite easily. People that work in the construction business, people that do tile and flooring, when they lay tile, that's how this is calculated. That's what they're doing. It's calculating how many 1 inch, 1 foot squares it would take to fill up this rectangle. That one should be, as I said, simple enough. Let's look at one more of those. If I've got 15 on my length, and I've got 7, let's say 7.5 on this one. Go back and put our decimals in it, because we will still be dealing with decimals quite a bit. Now, suppose you see something like this in your text, on a worksheet, on a test. You'll likely be given one like this with only these 2 numbers present. At this point, you will need to know, of course, that you need to fill in on the bottom and on this end. Because most likely when you see this, especially on CRCT, they will not give you all four numbers. They will give you one length and one width. And you will have to remember, don't get careless, you'll have to remember to go back and plug them in on each end. So 15 plus 15, of course, is 30. 7.5 plus 7.5 will give you another 15. So the area of this, I'm sorry, the perimeter of this figure will be 45. Now to get the area, we're going to do the same thing again. This time we're going to do 7.5 times 15. I get 1125, but remember this time we're dealing with decimals. I've got a decimal point right here, one digit behind it, so I have to back up and mark it off right here. So this figure would have an area of 112.5 inches. Remember to put inches squared, because we're talking about square units that will fit inside this figure. There's some other figures we'll be dealing with this time. One in particular is a parallelogram. Now, I will attempt to draw a parallelogram as best I can. You know by now my limitations in artwork. But this is going to look like something like a parallelogram. And basically all a parallelogram is a rectangle that just kind of got tilted one way or the other. That's the only difference with it. Now, you might see something like this given to you to find the perimeter area. Let's look at area on this one. If I am given an area of 12, it's kind of hard to measure this in like this. What you're most likely to see is a dotted line right here. This dotted line is going to represent the height of this figure. What's the actual distance from this bottom line to this top line? Okay? Now, if the height of this figure is 6, and I want to find the area, I'm simply going to take 6 times 12, and this time we would, instead of calling it length times width, this time we're going to call it base times height. And if my base would be 12, I could put that down here just as easily, times 6. So I would have 72 square inches. Now another way to look at a parallelogram is, if I draw my dotted line right here, you see formed to the left, obviously we form a triangle right here. Now if we were doing this with paper and scissors, we could actually draw this off on paper, cut this part off right here, and look at what we can do. We can flip it over and turn around and come back down to this end and fill it in right here. If I went back then, see if I can use my eraser, and we can take it. Now we've gone back and turned it back into a rectangle. So basically when you look at a parallelogram, you've just got a rectangle that's been pushed over, leaning over to one side or the other. So you're still finding the area the same way. It's referred to as base times height instead of length times width. I don't think you should have any trouble with those. You're still doing, again, basically the same thing as a rectangle.